So the topic is average acceleration means change in velocity by time interval. Okay, this is equal to average acceleration equals to change in velocity by time interval. That is, we can also write a average, this is short form of average acceleration, is equals to change in velocity can be written as delta v by delta t. Okay, this is average acceleration. Graphically we can see, suppose this is a graph of, this is velocity here, this is time here, velocity time graph, where the acceleration is plotted as in this way. Okay, now here we see, let us suppose here it is v1, here it is v2. Here also we can see delta v means what? Delta v means it is velocity difference by difference of timings. Okay, this is, it can also be written as in this way. Okay, so we took v2 and v1, and here it is, we can take it as t1, here it is t2. Okay, then extending this we can see, suppose that, yes, okay, suppose this is the point, we manipulate it, this is the point of acceleration, and extending this we saw this is the another point. Okay, and now joining this we will get this way, suppose it is point P and this is point Q. Okay, this interval is what? This interval will be delta V, and like this interval will be delta T. This is change in time. Okay, that is time interval, and this is change in velocity. Okay, now we see that finding the slope of this straight line PQ. How do we find it? By simply, slope means finding the tangent. Tan means base perpendicular by base. Okay, let it be theta. Let it be theta. And so average acceleration is what? Slope of a straight line, what? PQ. The slope is denoting the average acceleration. How? The slope is calculated by delta V by delta T. Why it is delta V and delta T? Because the slope is tangent. In trigonometry we know that how to find the tangent. It is simply perpendicular by base in a triangle. Okay, perpendicular, it is, if this is theta, it's perpendicular, and this is hypotenuse, this is base, this is perpendicular. Okay, in this right angle triangle, what we see, this is perpendicular, delta V, and this is what? This is delta T. Okay, so the slope comes to be delta V by delta T, and delta V can be extended in this form. Here it is V2, my god, this is V1, V2 minus V1 by V2 minus T1. Okay, so in the graph, to calculate average acceleration we simply find out the slope. Okay, the slope of a straight line, we simply use the formula of the slope, and to find the slope we go to the trigonometry, we take the tangent and the tan theta. Tangent is what? This is tan theta. Trigonometry, it is this right angle triangle, this is the perpendicular, this is the base, perpendicular by base is tangent, tan theta, and so the slope comes to be this, and the slope is called average acceleration. Okay, let's understand it with an example. Let us see this question. Find average acceleration between points A and B. Okay, this is the graph, and this is the graph, and A and B are the 2 points, and we have to find the average acceleration. Now what we studied, that average acceleration equals to slope of the line. We draw a line. Okay, and I have to find the slope now. Slope means make it a right angle triangle. At first we made it a triangle. This is right angle triangle, and this one is, this is theta, and now you find tan theta, that will be the slope. So acceleration average equals to slope of what? AB, slope of AB, and that is slope of AB means tan theta. Okay, tan theta is what? This by this, perpendicular by base. Okay, and this line is, let it be Q. BQ is what? BQ by, we have supposed this point as Q. Okay, this is not given in the question, we have supposed it. This BQ is, let us calculate, this is, B is at 20 and Q is at 10, so it will be 20 minus 10 by AQ is what? A is at 4 and Q is at 8, so AQ will be 8 minus 4. Okay, so the result is 10 by 4, so it is 2.5 on calculation. Okay, this meter per second square answer. So graphically we can calculate average acceleration in this way. Okay, we have to simply find out the slope of the straight line. We join the points, we make a right angle triangle, and we assume it as angle theta. We take the tan theta, and that is the slope. Okay, thank you.